So in this last section of this chapter, we're going to look at nuclear radiation today. So with nuclear radiation, you have to realize that there are different sources of nuclear radiation that you're exposed to all the time. It comes out of certain technologies like your laptop, your cell phone, different things like that. Now, these are known as background radiation. So they are nuclear radiation that arises naturally. Specifically with the monitors, cell phones, things like that, it's human-made background radiation. But there are natural sources in the world as well, because obviously there are radioactive materials all around in rocks and things like that. So we are continually exposed to radiation from natural sources such as the sun, soil, rocks, plants, your carbon-14 in your body, so on and so forth. So living tissues are actually adapted to survive these low levels of natural nuclear radiation. So we really don't have to worry about the low levels, okay? Just have to kind of think it is there, whether you notice it or not. Human-made sources make up about 20% of our everyday exposure. Now that can be higher or lower versus if you're always on a computer, TV, gaming system, whatever, versus if you're not. So levels of radiation absorbed by the human body are measured in what are known as REMS or millirems. Okay? So exposure not only varies based on what you're doing, okay, so from one activity to another, but also from one location to another. So if you think about it, you have different soil, different rocks, things like that all around you here than you would if you were, say, on the northeast, in the northeast, or on, like, in Seattle or something like that. So there are different background radiation levels in different cities. Okay, so you can see Tampa, Florida here has 63.7 millirems per year. Okay, so that is definitely not a whole lot just from living in that area. And then it can go up to Denver, Colorado, which has 164.6 millirems per year. Now, you have to remember, it's millirems over an entire year. So this really is not a lot of background radiation. But you do get different levels based on where you're living at the time. And then you can also get different levels of radiation based on activities that you do. So smoking a pack and a half of cigarettes per day gives you more radiation exposure in a year by a very significant amount than just living in, say, Denver, Colorado would do. Okay, 8,000 millirems per year versus 164.6. Now, airline crews, okay, they get about 267 millirems per year, right? So that's still relatively low for this. Radon is actually more dangerous than being on an airplane for that long. And then giving or receiving medical x-rays can give you 100 millirems. Okay. So radioactive substances have a wide range of applications where the radiation is used in a controlled way. We often talk about medical, but you can also use them in smoke detectors. Okay, so smoke detectors are designed to actually detect particulate matter, and it's pretty much whenever something disrupts the radiation that's being produced inside the smoke detector. So yes, your smoke detectors do have a small little piece of radioactive material in them, okay, which is why you should always test them, is because the radioactive material eventually will degrade. Okay. And then also used in manufacturing and agriculture. You can also use it a lot in biological research by tagging a specific protein or something that you're looking at within a cell so that you can track where it is or track where it is within a body. So here about the smoke detectors. Smoke detectors use alpha particles that produce an electric current. So the smoke particles in the air will reduce the flow of that current. And when the current is broken, that's when that lovely alarm goes off. So it's not a foolproof system. Okay, smoke particles in the air can set it off. So can enough dust particles if they're concentrated enough. So you might have heard me tell the story of when I was a TA at OU. We were working on a lab one day and fire alarm went off. We all evacuate. Found out later that it went off because there was a room on, I think, the second or third floor that hadn't been used in years, potentially decades. So it was a super dusty room. Nobody ever went in there. And a ceiling tile fell. It was great. So it kicked up all that dust, went right into the smoke detector and set it off. So yeah, we had to evacuate the building because of excessive dust. It's great. So nuclear radiation is used to detect diseases. It's used in ultrasounds every once in a while, obviously not with actually pregnant women, but CT scans. Okay, so the CT scan is actually tracking the movement of a radioactive isotope through your body. PET scans and magnetic resonance imaging, or MRIs. So radioactive tracers are short-lived isotopes that tend to concentrate in affected areas and are used to locate tumors or various other diseases. So it's also used to treat cancer, where controlled doses of nuclear radiation are used on tumors. So you know all those side effects that you get from chemotherapy, those are actually radiation sickness effects. Because it's actually using nuclear radiation in an attempt to destroy the cancer cells. It's not a perfect system, okay, so some of the effects do actually spread out from the tumor. And that is part of where a lot of cancer research is going right now, is how to specifically target just the cancer cells and leave everything around them fine. Because then you could really take out the side effects of all these cancer treatments. So that is a major area of research in cancer research right now. So radioactive tracers and radioisotopes can also be used on research farms, so to track different breeding techniques, different genes and things like that. It really depends on what the farm is researching. So they can also track how fast water moves through the soil into the stems or the leaves of the plant by putting the radioisotope in the water. Can also study biochemical processes in plants. Okay, so it can be used to track different molecules or even different atoms throughout the entire processes in the plants. And then the risk of damage from nuclear radiation really depends on both the type and the amount of radiation exposure. So the ability to penetrate matter differs among the different types of nuclear radiation. And we saw this in one of the last sections where the guy was able to block alpha particles using a piece of paper and then had to move up to lead in order to block the different types of radiation. So a layer of clothing or an inch of air can stop alpha particles, simply because in relation to the other types of radiation, they're huge, okay? So they can be stopped easily. Beta particles can actually get through a fraction of an inch in solids and liquids and can travel several feet in air. And several feet of material may be required for protection from gamma rays. So gamma rays don't really want to work with close to the source, okay? Because several feet of material, that would be kind of awkward walking around in several inch thick metal something or other, okay? So I also have some other stories about radioactive material from my time at OU. It's one of those stories of how is this guy allowed in the grad program and then how is he not kicked out. But he worked in the lab next to mine, which he worked with radioactive material. And the first story is he found out that smoke detectors have radioactive material in them. And so he brought in a couple old smoke detectors and one of the Geiger counters from the lab. And he brought them into the office, which was a huge no-no. You don't bring things from the lab into the office space. And then he proceeded to kind of dismantle the smoke detectors, found the radioactive isotope, put the Geiger counter up to it. Geiger counter went off. He freaked out and threw it in the trash can in the office. Great plan. And then, not too much longer after that, he was working in what's known as a glove box. So it's basically an airtight box that you can exchange the air in it. So you can have an oxygen-free environment inside the box. And then you have these gloves that you stick your arms in, and so you can work on whatever's in the box. Well, there was this machine in the box that you were supposed to put a little vial underneath it, and it would vacuum seal on the vial. And once the vacuum was sustained, it would shoot a needle down into the sample. Brilliant guy here. You were supposed to test that the vacuum was working by putting a little piece of paper underneath it. And if the vacuum is working, the piece of paper would move upwards. If it wasn't, it would just kind of stay there. Instead, he decided to use his hand. So he put his entire hand under the needle and ended up drawing the vacuum. And so the machine shot the needle that had recently been in radioactive material straight into his hand. Through the glove box, I might add. So yeah, that was a huge fix because those things are really expensive. And he had to wear a Geiger counter for the next several weeks and go to the health center periodically to make sure that he was not getting radiation poisoning. And yet he still didn't get kicked out and was allowed to join that lab. Anyway, moving right along. So, high levels of nuclear radiation can actually cause what's known as radiation sickness. Okay, so high concentrations of radon gas can also be hazardous. So the radon gas can produce enough radiation to give you that radiation sickness. Radiation sickness is like nausea, weakness. I mean, there's a lot that goes into it. And just overall, it's basically like your body is being poisoned by this. So with radon gas, it can actually, well, it's produced by the decay of uranium-238 that's present in rock and soil. And if you have cracks in your basement, that radon gas can actually get into your basement and then just kind of sits there. And if you walk into it and start breathing it in, it can be very bad for you. So radon gas tests are actually really common in buildings. You might see them come out and test for it every once in a while. There are different kits that you can get to test it in your house. And that's why people are very concerned about cracks in the foundation, aside from the fact that, the house could collapse because of those cracks in the foundation. But if it's cracks underground, like in the wall of the basement, that can be a huge issue because it can let in that radon gas. Again, not something you'd want. But we are actually going to pause here and continue on with a couple practice problems in the next video.